Bella, where the heck have you been, Loca? Well, listen, you can tell me, but I can't hear you, and more importantly, I don't care. We've got some math to do. Specifically, our goal up until now has been using equations of lines to find their graphs. For the rest of the unit, our new goal is actually to ask that question in reverse. Namely, if we have the graph of a line, or we happen to know some stuff about that graph at least, how can we find its equation? So, with this question in mind, right, it's going to be following us for the rest of the unit. If you think about it, we've actually already done a bit of this. For example, take something like this. I want you to find the equation of the line with a slope of -3 and a y-intercept of 1/2. The equation of a line with a slope of 0 and a y-intercept of -5. Take 30 seconds, take a minute, pause the video. Remember how this works, right? I've got slope, I've got y-intercept. Let's find the equation of our line, let's say in slope-intercept, or y equals mx plus b form. Pause the video, have fun, go ahead. I'm a werewolf, and stop. So, if I want to slot everything into y equals mx plus b form, again, because I've got that nice little form, I know m, our slope, is just the coefficient of x. So if I know that my slope here is -3, right, this is going to be our value of m. A y-intercept of 1/2, well, that tells me that's going to be our value of b. All I need to do is plug into place y is equal to -3x plus 1/2. Same thing over on the right. Right, my slope of 0, so 0 is going to be m, my y-intercept of -5, -5 is going to be b. Slotting into place, right, I know that y is equal to 0x plus -5, but of course, 0x is 0 times x, which is just 0, plus -5, so that's just -5. Notice, by the way, y equals -5. What kind of line is this? 5, 4, 3, 2, 1. Very good. Hopefully you remember this line is sad. No, it's horizontal. Anytime that I have y by itself, remember, that's telling me x can be whatever it wants, but the elevation above or below the y-axis cannot change. That gives me a horizontal line. This, in fact, is going to be the first of our 5 cases. We can continue to up the ante with different ways to find equations of lines. And we can and will complicate this down the line, but every variation of this that we'll see all boils down to this essential idea. As we know from graphing, as long as we can find the slope and any point on our line, maybe it's the y-intercept, maybe it's not, we should be good. For now, we're going to focus on versions of that task where that point does happen to be the y-intercept. And we're going to introduce our first 3 cases of reverse engineering our equations of lines from their graphs or information about their graphs. Don't worry, we'll see the last 2 next time. Our first case, as we saw above, if I know the slope and the y-intercept, all I need to do is plug in to my slope-intercept form, right? So this, as we saw above, is stuff that we already know how to do. A different version of this that you might see, maybe I don't explicitly tell you what the slope of the line is, but I do tell you 2 points on the line where one of them is going to happen to be the y-intercept. So our second case is going to be a problem like the one below, where I give you the y-intercept, in other words, where my graph crosses the y-axis, and a point on that graph. So for example, I want to find the equation of a line that passes through the point -3, 5 and has a y-intercept of -1. Think creatively, think strategically. What tools do you know? Again, as long as I can find a slope and a y-intercept, I can slot right into my slope-intercept form. Think creatively about how I could use these pieces of information to achieve my goal. Go! Alrighty, well, you might remember one tool that's really powerful for us is our slope formula. And slope formula, as long as I have any 2 points on my line, if I take the y-coordinates of the first and second point and subtract them, divide that by the difference of the x-coordinates, that should give me my slope. Well, notice, if I tell you the y-intercept, I've got a point hiding in disguise. What's the coordinate if the y-intercept is -1? Well, to find the y-intercept, x needs to be 0. So that tells me the point 0, -1 is on my graph. Using these two pieces of information, all I need to do is plug into my slope formula. So this tells me that slope, maybe I'll call this first point my x1 and y1. I'll call my second point here my y-intercept, my x2 and y2. All I need to do is slot into place. So I'll say y2, which here is -1, minus y1, which is 5, over x2, which is 0, minus x1, which is -3. That should give me my slope. Well, -1 minus 5 is -6. 0 minus -3, well, that becomes 0 plus 3. So I have -6 over 3, which is -2. So that tells me the slope of my line is -2. My y-intercept, notice, is -1. All I need to do now is plug into my y equals mx plus b form. So y would be equal to -2x minus 1. Cool. Let's get a little bit more practice using this idea. So I want you to find the equation of each of these lines. Again, the idea is that if I've got my 2 points, even if one of them is the y-intercept, one of them could even be the x-intercept like in the first one. If I use my slope formula, I can find my slope, and because my y-intercept has already been made clear to me, all I need to do is slot into place. Give yourself a minute, 2 minutes, 3 minutes, pause the video, have fun, let's do it. Go, 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 go. Alrighty, so my x-intercept is 15, my y-intercept is 10. Let's think creatively. Remember that to find the x-intercept, what do? Well, I need to plug in 0 for y. So hiding in plain sight is the point 15, 0, and if the y-intercept is 10, then the point 0, 10 is also on my graph. Using my slope formula, I know that y2 minus y1 over x2 minus x1 will give me my slope. So let's say x1, y1 is the point on the left, x2, y2 is the point on the right. Again, it does not matter the order. You're welcome to pick whichever one you want to be your first point or your second point. But slotting into place, I know y2 here is 10, minus y1, which is 0, over x2, which is 0, minus x1, which is 15. That gives me 10 minus 0, which is 10, over 0 minus 15, which is -15. 10 over -15, both of these have a common factor of 5, so this reduces to -2 over 3. Knowing that my slope is -2/3, right, my y-intercept is 10, so plugging everything into place, y equals -2/3 x plus 10. And for the equation on the right, I have 0, -6, and 3, 9 as my points. Again, I have a y-intercept hiding in disguise here. Notice 0, -6. When x equals 0, I get my y-intercept. Well, let's find our slope. Slope is, of course, equal to y2 minus y1 over x2 minus x1. Let's say here, let's flip it around. Why not? Let's make this point on the right our x1, y1. Let's make x2, y2 our y-intercept. Plugging in, all I need to do, right, I'm going to take y2, which is -6, minus y1, which we've identified as 9. x2 is 0, minus x1, which is 3. -6 minus 9, this is -15. 0 minus 3 is -3. -15 divided by -3 is +5. Again, my y-intercept here is 0, -6. That tells me that b is equal to -6. Plugging in, I know that y is equal to 5x minus 6. Very nice. So we've got our second case. If I give you a point and a y-intercept, I should pretty easily be able to use slope-intercept form by finding the slope. All I've got to do now, case 3, and then we'll leave cases 4 and 5 for tomorrow. Let's say that I, instead of giving you 2 points, give you a graph. Using the graph, right, maybe there's a little bit more information that I need to use to my advantage. Think strategically about how I'm going to weaponize it. Maybe, I don't know, maybe it could even be a little bit easier if you think creatively. I don't know. What do you think? Play around. Can you tell me the equation of this line? Again, go for a slope-intercept, y equals mx plus b. Can you find me a y-intercept? Can you find me a slope? Who knows? Go. Alrighty, well, if I happen to look at this, all I need to do is find 2 points because I know I can find the slope using the rise and the run. I see a nice point here, a nice point here. Let's look at this. I've got 1, 2, 3, going up and down, 1, 2, going left and right. So I have a run of 2, I have a rise of 3. Notice my line is decreasing, so that gives me a line with a negative slope. So from my graph, I can deduce that negative 3/2 is my slope. And I also know that this point here, right, well, its coordinate, 0, 2, that is my y-intercept. That's where I cross the y-axis. So that tells me here that my value of b, my shorthand for my y-intercept, is 2. Well, would you look at that? I've got everything that I need. I could say that y equals negative 3/2 x plus 2. But what if I don't believe that, right? Maybe I want to use the method that I used above to make sure. Well, I know 0, 2 is a point. I know that this guy, this other pink point that I've got here, well, its coordinate would be 2, negative 1. Let's just check using our slope formula that this is correct. Well, I know that slope is y2 minus y1 over x2 minus x1. Let's say that this point up here, maybe we'll call our x1, y1. We'll call this guy our x2, y2. Again, doesn't matter. But all I need to do is slot into place. So we'll say y2, negative 1, minus y1, positive 2, over x2, which is 2, minus x1, which is 0. Negative 1 minus 2 is negative 3. 2 minus 0 is 2. Well, would you look at that? Negative 3/2, negative 3/2. We're happy. So when you have a graph, you're welcome to use that visual information to your advantage. You can find the rise and the run just by counting your grid marks. Let's do 2 more, and then you're free. Cool. Find the equation of the line. Go, tell me the slope. Tell me the y-intercept. And let's find our equations. Alrighty. So, with this idea in mind, notice over here, again, I can use my slope formula if I want to, but I can also think creatively. I've got a point right here. This guy happens to be on the y-axis. It's my y-intercept. Its coordinate, if I count down my tick marks, I go 1, 2, 3, 4, 5, 6, 7 down. So 0, negative 7, this is my point. I know it's on my y-axis, so the b value, of course, is going to be negative 7. And then this is a horizontal line, right? We know that horizontal lines have a slope of 0. They are totally flat. They are not sloped at all. So with these ideas, I know that y is equal to mx plus b. So I've got 0x plus negative 7. Of course, 0x is just a fancy way to say a big ol' 0. So I know 0 minus 7 is just negative 7. Y equals negative 7 is the equation of this horizontal line. And finally, for number 2. Well, all I need to do is find 2 points. Notice I've got my y-intercept right over here. This guy is 0, negative 2. So that tells me that my b value is negative 2. And if I look at my rise and my run, it doesn't matter which point I choose. Maybe I'll pick this one down here. Who cares? Doesn't matter. So if I go up or down, so I go 1, 2, 3, 4, and then I go over 1, 2, 3, 4. So my run and my rise both happen to be 4. I know that this line is positively sloped, so it's going to be positive 4 over 4. So the slope here is going to be 4 over 4, which is 1. Plugging in, I know that slope is equal to mx plus b. m we've identified as 1x. Our b value is -2, so you can leave it as y equals 1x minus 2, or of course you can simplify 1x to just x. Fantastic. Congratulations. You now know the first 3 cases for finding our equations of lines. The last 2 are not particularly tricky, but they rely on a new form of a line. Again, all forms of lines might be powerful. There is another form of line that is particularly powerful for finding equations. We will discuss it when we see each other next. But until then, take care, be well, get some sleep, and don't listen to those wolf howls out the window. Goodbye.